Okay, let's take a look at what we're being asked to do here on this free response question. So we're given a graph, and this is the graph we're calling G, right? This is our G-defined graph. And then we're given this other equation, and we're calling it P. Okay, so first we're asked to state the domain and range of the function G. So domain, we start at the left, and you move off to the right. So the first thing we encounter is a closed dot at -5, so we write bracket -5. And then as you proceed to the right, we notice that there's a solid line, so it's continuous until we get to +1, right? In +1, we notice that there is a open circle, right? And there's no other point around us to say that 1 is included, so we have to do our jump over the number 1. Because there is no y value for number 1. We say that f of 1 is undefined, right, or it does not exist. There's not a y value for that given x value. So we jump over there, and once we get on the right side of 1, the arrow says we go on to infinity. So we have a two-part domain to the left of our open circle and then to the right of our open circle. Okay, and then the range. The range always starts from bottom to the top. Okay, so hopefully you notice here on the far right side that there's an arrow on our graph, which means this arrow goes down in this direction indefinitely, right, forever. So as we do our domain or our range, we're going to start at -infinity because -infinity is the smallest thing that's there. Okay, we're going to start working our way back up. So we're going to work up our graph. Notice that we have all these possible y values, okay? And we also have some y values over here from our graph, but those are already given to us on this line here, right here. Here is where y equals 1. So even though there's an open circle there, we do have that y value there, so that's good. And we continue until we get to +3. So because of our arrow on this absolute value graph, our range is going to be from -infinity to +3. Everything between there is going to be acceptable and a y value possible. In case there's a couple times where we have multiple y values, but they are all included in there. Okay, so now it moves on to your P function, and it says, how is this graph different? So what have the transformations been done? Okay, so one of them we can look at is the negative in front. The negative is an x-axis reflection. So we can say P of x has been reflected, right? We're going to use whole sentences across the x-axis, right? That is a complete sentence talking about the reflection, that negative portion. Okay, and the +4 underneath your radical means it has been translated, transformed or moved 4 units to the left. And the +1 on the outside means that it has been moved 1 unit up. And this is, of course, from the parent function y equals √x, which traditionally starts at the origin and grows in that direction. Okay, so that's our parent function. So this one has been moved 4 units left, 1 unit up, and reflected across the x-axis. So the second part says graph this. Okay, we're going to graph this. So let me erase all my stuff right here. Let's erase all of this. So from our origin, we go from the origin 4 left, 1, 2, 3, 4, and 1 up, and this is our new origin point. So here we're going to use our pattern, okay, the pattern for all of our square root graphs. And because it's negative, we're going to go 1 unit right and 1 unit down, and we're going to put another point. Okay, and then we go back to your origin point, and we're going to go 4 units right and 2 units down. And then we're going to go back to our origin point and go 9 units right, 9 and 3 units down. Because however far you go in the x direction, you have to go the square root of that in the y direction, in this case in the negative y direction. So that would be the graph of our p of x function, negative square root x plus 4 plus 1. Okay, so you get 1 point for the graph and 1 point for the answer. Okay, next, state what would graphically be true about p of x equaling g of x. So that's when the y value of p is equal to the y value of g. So what is happening is if p of x is equal to g of x, so we use complete sentences, right? This is what they're asking about, so that's what we're going to write about. Then the graphs of p and g intersect, right? If we have the same y values, we're talking about the intersection of our graph. Okay, so you're going to get the point somewhere if you say that the graphs are intersecting, because that's what happens when we have the y value of p equaling the y value of g. And then the second part says, state how many x values are there going to be? How many times will this graph cross? Okay, it's not asking for where it crosses or when it crosses. It's just asking how many times is it going to do it. So let's look and see. Well, I have one intersecting point right there that I have drawn on my graph. And I have some points out here, right? If I continue my absolute value and my other one, it looks like it's going to cross again somewhere out there to the right of 7. Okay? I don't know where, nor do we care. It just says how many times is it going to cross. So it's going to cross 2 times. P of x will intersect g of x 2 times. Okay? We don't care what is the x value. That's not what the question says. It just says how many times will these y values be equal. How many times will the graphs cross? The answer is twice. Okay, and the last one, we have some algebra. Find the value of this little functional thing here, right? That little equation. Either show your work or explain. So let's show our work. How do we get P of 12? Well, P of 12 is found by plugging 12 into your equation for P. Right? So we can do all of this nice simplifying math down here. Negative 4 plus 3. Nope, negative 4 plus 1. And we get a P of 12 is negative 3. Okay, so I have shown you my work. Now, what about G of 4, right? So what about G of 4? So G of 4 and G of negative 5 come from where? Come from your graph. Okay, so G of 4 equals, what is the y value when Gx is 4? A y value of 2. So G of 4 is equal to 2. And G of negative 5, when x is negative 5, the G value is down here at negative 4. Okay, so I have explained how I have gotten G of 4 and G of negative 5. So now I am just left to plug these values in. Wait, not 3, not 2, but 3 times. P of 12 was negative 3, right? Minus 2. G of 4 was positive 2. And also G of negative 5 is positive 4. Okay, so we have to do all of our nice simplifying to get this number done. Okay, so the first thing we're going to do is all of this multiplication. Right, 2 times 2 times 4. Sorry, this is not positive 4, is it? This is a negative 4. Sorry, this is a negative 4y value. So let's see. There's negative 4 and a negative, so that's a plus 16. Right, 2 times 2 is 4. 4 times 4 is 16, and a minus become a plus. So we have 3 times, oh, that's a negative, sorry, negative 3 right there. I'm sorry, I forgot that. So this is negative, positive 13. There we go, 3 times 13. 3 times 13 is 39. Okay, so we need all of these parts. You get 1 point for finding P of 3, G of 2, and G of negative 5. That's 1 point. And then you get 1 point for figuring out that this whole entire gray thing here comes out to 39. Okay, so that is your FRQ. That is covering how F and G relate to each other. Hopefully this is good, and you'll do fantastic on your quiz tomorrow.